In this example, we have Merrick Stevens is a sports analyst working for the ACE Sports Management, a sports agency that represents over 200 athletes. He's interested in understanding between an NBA player's salary and his physicality and performance. The data contains information on 30 competing NBA teams and 445 players. Create a regression tree model for predicting an NBA player's salary. Select the best pruned tree for scoring. Display the full-grown, best pruned, and minimum error trees. So it seems that we have a problem. It's a regression problem. It's not a classification because the goal is to get the player's salary. The salary is a numerical variable. So first, let's call the data. Let's get some libraries. We need the caret. We need our part. We need rpart.plot. And we need another library, which is forecast. Forecast, we're going to use a function called accuracy. So install the package forecast, then load all of these libraries. Then the data is NBA data. And I'm going to look at the structure. So we have so many data. Let me try to get trying to getting these variables because we have so many variables. So I do not know what each variables mean. So these are from the appendix in the book. So we have the player, we have the name, we have the position. Where's the position? There's no position here. We have age, height, weight, salary, season. Do you have the season here? No season. For example, some of the stuff that I do not know, the FG mode, FG made. FG made is total number of baskets made. FG attempted is the total number of baskets attempted. FG percent, which is the field goal percentage. 3P made, the total number of three-pointers made. 3P attempted, number of attempted, etc. FT made, free throws made. FT attempted and FT percent. Offensive rebounds. I don't know what is this. Defensive rebounds. You should know this. I'm not familiar with basketball, by the way. I'm not a basketball guy. So total number of players, total times player caught basketball after missed shot when playing offense. This is the defensive rebounds or something probably. Anyway, so we have so many variables, and the idea is look at the statistics, look at the sports, look at how they maybe they classify, they decide the salary of a particular player using so many variables. Maybe these are some of them or most of them or more. I mean, maybe some clubs or some people look at all of these variables. Some of them, they look at some of them, etc. But it's very interesting to know. Anyway, so we would like to use he would like to use these variables or some of them to just estimate the salary of the basketball player. As we did before, first let's partition the data. By the way, for the trees, this is the way that we are doing a typical tree. So we are growing a full tree, then we look at the CPs, then we prune the trees. Before prune the tree, we look at the minimum error tree, then we look at the best pruned tree. So the question is, maybe you may ask about why cannot we create cross-validation, use cross-validation techniques? No, we can. Excuse me for a second, just a second. We can use cross-validation technique, but if we're going to use a cross-validation technique, we may not use the pruning techniques. Anyway, let's focus on the typical way of doing things here. Maybe I'm going to extend the example and do or use cross-validation techniques. So let's partition the data first into two parts, the training and validation. So we have 70% for the training and validation is going to be 30%. And let's look at the data. We have 445 observations, 25 variables. Look at the variables. Maybe there's one variable we have to exclude from the tree, which is the player number. This one has nothing to do with the predicting the salary. So we're going to take it off. So let me go up here, and I'm going to say my data. Just keep my data as is. Just take off the first variable. So let me Command Enter. So we got 24 variables. After that, I'm going to partition the data, right? So after partitioning the data, we're going to build and view the default tree, right? Default tree. So let's call it the default tree as we did before in the previous example. R part, salary is our response variable, and the training is our data. And the method is going to be not class, it's going to be ANOVA. Then we look at the summary of this if you would like. Default tree. So this is the tree, default tree, and these are the CPs, the minimum error of the trees, the number of the splits, and the standard error. So let's look at the view. Let's view the tree. Do you have another one? Let's view the tree, PRP, to view the tree. Let's use the same arguments. Type is 1, extra is 1, and under is true. So this is the full tree. So for instance, we have the first split occurs with if the player it's the game start. I mean, who starts the game? If he started in the games less than 172 games, then we look at another split which is 40. But if he started with a game with more than 172 games in a season, look at the salary first. This is 4.2. This $4.8 million. 4.8 is the average salary for all of them right now, without doing any split. We have 313 is number of the training data. If a person started with more than 172 games, then let's see FG. What is FG? Total number of baskets made. Look, this is the most important criteria the tree gives you. If he makes greater than 6.1, I don't know, this one in thousands or something maybe. Or per game, maybe. No, it's or not 1,910s or something. Or maybe indices, I don't know. Total number of baskets made. 6.1, I don't know. Anyway, so you can't tell. Anyway, so the turnover is the other split. Then we have here the age, that is a split. So, but this is the default tree. And as we said, the default tree, they are using 0.01 as a CP, right? As a complexity parameter. And this is not enough. We would like first, the typical thing to do is to grow the full tree. Full tree, we are using 0 as a complexity parameter, okay? R part, salary. So the data is trained, and the method is ANOVA, right? And we are going to use the CP equals to 0. Min split is 2. Min bucket is 2 or 1. Then we can technically say, what is the PRP? Let's view it. Full tree, type is 1, extra is 1, and under is true. So let's look at the full grown tree. It's a complex, huge tree, right? It's a complex and huge tree. So let's look at now to the CP numbers, right? To the CP numbers and try to get the minimum trees. So how to get I would say print CP. We can have a huge print CP. Print, because we have a huge print CP full tree. We're gonna have a huge numbers here. Command Enter, as I expected. Anyway, we don't need to look at the whole thing because it's clear from here. So the first tree we look at the error, right? This is 1, this is 0.8, 0.7, 0.57, then start increasing. So this is my minimum error tree. The tree that has 3 splits. 3 splits, that means 4 terminal nodes. So this is my minimum error tree. But the question is, if you add 1 standard error to this tree, can we get something within this number? The number that you're going to get. So 57% plus 6%, we're going to get about 63%. Are you getting something between 57% and 63%? A simpler tree. Simpler means something above here. Do you have something within the ranges between 57% and 63%? No, because this is 70. So this has higher number, right? So So what to do? So the minimum error tree is the same as the best pruned tree. So the best pruned tree is the same as the minimum error tree. So it is the tree that has 3 splits. So let me copy the CP and create the best pruned tree. So let me hide this. So let me call this best pruned tree, which is the same as the minimum error tree. So the best pruned tree is going to be R part celery, then train method is ANOVA, then we have CP equals this, right? Then PRP pruned tree type is 1, extra is 1, and under is true. This is nice tree. So it depends. Still number of games is the top node, is the root node at 172. If a person starts with greater than 172 games, then we look at number of baskets he made. Then we look at the turnover or the age. So all of these will decide the salary. Look at this highest salary here. I have $20 million. Yeah, so this is the best pruned tree. Now we can do some predictions and evaluations. So let's do let's use this model to predict. Let's do the prediction. So predict on the validation data, the pruned tree using the validation. After that, we can look at the accuracy function to calculate the performance measures. But the question is, if you calculate the predicted, not predicted here. The question is, if you calculate the evaluation performance, so what, then what? How do you compare them? Actually, these guys do not tell you exactly what's happening. We look at the unit that we are using, and the RMSE, for example, the root mean square error, which is about 4 million something. We do not have anything else to compare it with, so it's hard to tell whether this number is good or no, or high or low. But if you look at the salaries ranges from where to where, this may help you to tell whether this error is high or no, or kind of. But still, this is not something that we can rely on. It's a good idea to compare different trees or different models to tell which RSE is better, or EE, or etc. So after that, we're going to score. We have 2 players with that. We got their data and we would like to predict their salaries. So if we look at my score, this is my score. This is my score. We have player 1, 2, 3, and we have all of these information. And we would love to know something about, or to predict their salary, how much we would offer them, or evaluate their salary, or at least value, or tell about their market value or something. So to do this, we can say predicted, right? Predicted salary, predict, or we can add this to my score. Let's add it to my score. My score, predicted salary, predict pruned tree with my score, right? So we're going to have our score to get this salary. So let's go to my score again, because I added these to them. So these are the value for these players. So the first player, we may pay him, or his value is 12 million. The other one is 5 million, 0.7, 5.7, 5.7. We have 12 here. So these are the value for these players, or the predicted value, let's say, or the predicted salary or something. It doesn't seem, it's not necessarily to be the value, but this is my kind of interpretation or something. So yeah, this is the whole thing about the regression tree and how we predict the numeric number. We can also use, as I said, we can use a cross-validation technique. Maybe I'm going to do the same example using cross-validation technique in a different recording. Thank you.